let's start. Short introduction from my side. In this track, we'll access where we stand with transport and storage of hydrogen, and discuss how we can help overcome many challenges by harnessing the expertise in the gas sector. Production sites have to be connected with consumption. Once by using several transportation modes, either pipelines, ships, trucks, in a liquefied, compressed, etc. All of them deserve to be analyzed. Hydrogen can also be stored. Both transportation and storage are integral part of the infrastructure needed for the above said connection to happen. For instance, some time ago, our group of experts on gas, recommended the ECE member states to leverage on the existing conventional and natural gas infrastructure as a cost-effective entry point for developing low-carbon alternatives, such as hydrogen. The infrastructure in question includes both transport and storage. Sorry, because right. Then retrofitting and repurposing current existing infrastructure is by far the most cost-efficient way to develop those markets. Several pathways could be used to allow hydrogen deployment and development. For instance, the using of existing asset pipelines when and where they are redundant, duplicated, or parallel lines, as in the case of in some few countries. In some others, many others, I would say, a very good solution is to start by mixing or blending the hydrogen to the natural gas stream. Do not underestimate the widespread NIMBY effect. So this is more and more challenging to build new infrastructure. Therefore, existing ones have to be used as much as feasible. By the time the system is well developed, depending on the places, potentially decades, and depending on, say, countries and regions, potentially pure hydrogen infrastructure will be used. I cannot resist to say that as regarding the statement, one of the statements said by Deputy Executive Secretary in his opening. I think that hydrogen shouldn't be seen as a liability. It's not hazardous material, but it's an asset, and this entity is UNECE has a vast experience in setting regulations, norms and standards, and need to contain and transport gases such as hydrogen. So we should take advantage of that and build on to what we already have. Then about the speakers today, we have 5 speakers who will talk us through challenges and opportunities I mentioned, and they were in the previous slides: blending, storage, pipeline, retrofitting, and so on. I will quickly refer to the speakers in such a way that then we go one by one. First one, I will introduce all of them in this address. Is Abel Enriquez, is EU Regulatory Affairs Manager in ENAGAS. He's also here, is the person that will share with us what is happening in the roundtable of transport of the European Clean Hydrogen Alliance. He is the Sherpa of one of the co-presidents of the roundtable, so that, as you know, usually the work is done by the Sherpas, so he's devoting dozens and hundreds of hours to this topic. Second, we will have Gael, and Gael Couchois is the principal consultant in carbon limits. And there's a project, it's the Restream project, to reuse the current oil and gas infrastructure. And we will see what is happening at, let's say, European scale. Then we have Eva Hinen, is the head of policy, energy policy in Tuga, in Germany. Very active member of the European policy landscape and can share with us the perspective of a very relevant segment of the infrastructure value chain, which is the DSO perspective. Last here in the list is the second, but my one is sorry. Next is the Thierry Leperc, is the founder of Soda Bend in France, deeply involved in a very interesting project comprising production, transportation, and usage of hydrogen. Hydeal is a flagship in this huge ocean. We asked Thierry to focus on in this case on the transportation, on this part of the value chain, on this segment we are trying to cover. Last but not least, for sure, is again one of my friends. All of them are my friends, so sorry. Is Siegfried Kies, is the head of business development in Rach, Austria. And is one of the persons I know with the deepest knowledge of the underground gas storage facilities, and either for natural gas, for hydrogen, or whatever. He's a very big expert and top manager. So, and then I will open the floor for reactions, comments, and questions. I have also a list of questions in case that just to start the discussion. So let's go then to the panelists that who will share with us very good insights and expertise. Abel Enriquez, please. Floor is yours.
Thank you very much, and thank you to UNECE for the invitation of being here today and speaking about the European Clean Hydrogen Alliance, more concretely about the transmission and distribution roundtable. Moving to the next slide. I don't know, how can I move the slides?
I'll move them, just say.
Okay, yes, please, next slide then. Yeah, thank you. So just first of all, let me introduce very shortly the alliance. The European Clean Hydrogen Alliance, well, it was launched last year in July 2020. On that day, on the 8th of July 2020, it was when the European Commission published a communication describing its views on a European hydrogen strategy. In this European hydrogen strategy, the Commission sets a target of 6 gigawatts of hydrogen by 2024 and 40 gigawatts of hydrogen by 2030. Therefore, the Alliance has two main objectives according to this strategy. The first one is to identify a pipeline of projects which will help to accomplish the EU hydrogen strategy targets, the ones that you also have on the screen. And the second objective of this alliance is to gather a list of regulatory barriers that those projects delivering the strategy are facing. Therefore, the alliance is an opportunity for industry players to promote their projects and to find their potential and to find potential partners. Although the alliance has not a specific budget and the regulatory changes are not guaranteed by the Commission, we are aware that the European Commission will make their best efforts to ensure and to facilitate that the pipeline of projects which are part of this alliance will go ahead. In terms of overall process, you have in the low part of the slide as a brief description. So at this moment, the alliance has been defining categories of projects, also called archetypes, the eligibility criteria and data sets. Probably by next week, the European Commission will launch a project collection exercise to collect input from the almost 1,000 organizations which are part of this alliance. And then with this, once the project collection exercise is finished, there will be a matchmaking session. There will be a process to elaborate and to develop the list of large-scale integrated projects. And at the end, we will arrive to the pipeline of projects, the official list of the alliance. Before that, the Commission has promised to provide funding advice to those projects, to those large-scale integrated projects, so they can get access to financing in the various programs which are open at the moment. In the next slide, you will see that the alliance is structured around 6 roundtables, one on production, another one on transmission and distribution, energy sector, industrial applications, mobility, and residential use. The one that I'm going to talk about today is the transmission and distribution, and it's linked to the topic of this workshop. And this roundtable is facilitated by NSOC. They provide the secretary role, and then is co-chaired by 3 companies. If you click one more time, Branko, it will appear. And there are 3 co-chairs, leading this transmission and distribution roundtable, together with around 40 companies which are part of that roundtable. In the next roundtable, in the next slide, you will see that the transmission and distribution roundtable has agreed on a number of categories or archetypes that you have in front of you. Due to the time limitation, I will not enter into the detail, but just to let you know that there will be an archetype for transmission and distribution pipelines, another one for marine storage and handling terminals, a third one related to shipping. Shipping is also a way to transport hydrogen. And then there is a 4th archetype, which is about inland distribution by truck loading, rail, barges, or other technologies and logistic options. In terms of transport technologies, is written on the low part of the slide. The roundtable is really open and inclusive, and we are not just limited ourselves to liquefied hydrogen or pressurized hydrogen, but also planning to study and to assess projects dealing with ammonia, with other hydrogen carriers like liquid organic hydrogen carriers, methanol, methane, etc. So a number of technologies are part of this roundtable, and they can qualify to become part of the official list of pipelines, pipeline of projects. In the next slide, and yes, it's the last one, I'm presenting to you the vision. This vision is, on the 10th of March, the CEOs of 40 companies which are part of this roundtable agreed on 5 key principles which constitute the common view, the common understanding of the roundtable. This is about the role of hydrogen and hydrogen infrastructure, and the role in the future energy transition process, and also delivering the EU energy and climate targets. The first one is about the role of hydrogen as enabler, being at the heart of the energy system, being a paramount element for sector integration, integrating electricity and gas infrastructure, and making the whole energy system more sustainable, reliable, cost-efficient, and flexible. And this is fully coherent with the strategy of the European Commission and with the views of the European Union. Second principle is about the role of hydrogen transportation, distribution, and storage. As we said before, this will be based in multiple transport modes and in multiple transport technologies. Third point is that there is a common understanding and a common belief that hydrogen transport, distribution, and storage infrastructure, which is necessary to handle renewable and low carbon hydrogen, will surely contribute to achieve the objectives of the European Commission hydrogen strategy and the EU Green Deal. And then in this point, it's important to understand that there are different ways of transporting and distribution and storage hydrogen, and all of them are part, as I said, of the roundtable. We are working on an inclusivity principle, and then as Francisco mentioned before, for instance, in the case of pipeline, we are looking to retrofitting pipeline or to the options for repurposing or also to projects which are planning newly built hydrogen pipelines. The same for marine storage and handling terminals. They will play an important role, and also other means of transport like trucks or barges or rails or trains. The fourth principle is about the future hydrogen infrastructure should be developed to create a EU-wide market, a EU-wide hydrogen market. And this should be based on principles like non-discriminatory treatment and transparency. So for this, there was also a full agreement in the roundtable that these principles should be some of the major principles guiding this development. And the last part, and maybe the most relevant for this fora, is about enabling solutions for intra-EU trade and also for non-EU imports of hydrogen. And these two elements, intra-EU trade and non-EU imports, will be important in delivering the EU hydrogen strategy, and also in the sense of reaching long-term carbon neutrality. For sure, the ports will play an important role, an essential role. They will become also entry points for hydrogen from other regions of not only of Europe, but also from other regions of the world. More concretely, the European hydrogen strategy is mentioning the imports from Eastern Europe and Southern and Eastern Mediterranean countries in the neighborhood of the European Union. So this is also, and that's why this is also important in this forum of UNECE. And with this, I'm just finishing my time. Thank you very much for your time. And thank you for your attention. This alliance is also fully in line with your carbon neutrality project in UNECE, so they can go hand in hand in delivering the energy transition. Thank you very much.
Thanks, Abel. Let me say here something. I would like to avoid just being too European Union centric. Here, ECE region covers Northern Hemisphere, 56 countries, and we could give the impression that we are focusing here in the European Union. In the previous session, we had Konstantin and Tatiana, so that the main focus was on the eastern part of the region. But anyhow, please apologize if this seems to be so European Union centric. Anyhow, as Abel was saying here, this is a global topic, so that we even the external dimension is trying to be covered. So let's go to the next, Gael Koshua, on the Restream project. Gael, floor is yours.
Thank you very much.
Please, all the those not speaking, I would ask to mute microphones. Thanks, Gael, please.
Thank you very much. So yes, I'm Gael Koshua, a principal consultant in Carbon Limits, a consultancy based in Oslo, focused on making a difference to climate change mitigation. So today I will give you a quick presentation of a project we are currently carrying out for the account of 4 oil and gas associations, IOGP, ENSOG, GIE, and CONCAVE, the Restream project. So the project studies the reuse of oil and gas infrastructure for hydrogen and CO2 transport in Europe. And we are doing this study together with our partner, DNV. Next slide, please. So laying and building new infrastructure onshore is more and more difficult, and it will benefit the society to reuse the oil and gas infrastructure when available. So the objective of the project is to assess, in fact, this potential for reuse in Europe to carry CO2 or hydrogen, and provide fact-based information to policymakers and stakeholders to inform debates on energy and climate policies. So next slide, please. So to reach the objective, the project falls into 6 tasks. So first we collect data on pipelines towards the TSOs. Then we collect data on potential location of sources and sinks for CO2, hydrogen production, consumption, and storage location. From there, we assess the reuse potential and identify case studies for which we will compare reuse option to new build option from an economic perspective. Finally, we will identify challenges that need to be tackled and investment requirements to unlock the reuse potential. Next slide, please. So as for now, we have collected data for offshore, onshore oil and gas pipeline and did an initial screening of the pipes. We scored the pipe for reuse based on material of construction, pressure, thickness, diameter, and safety consideration. Then, as we identified sources and sinks, both for hydrogen and CO2, we will calculate a business potential and will perform a more detailed assessment for the case studies. Next slide, please. So to identify locations of sources and sinks, we mapped the current location of, for instance, wind and solar farms that could become hydrogen producer in the future, and did the same for each potential consumer, so from cities to train station to iron and steel plants and producers as well, so also ports for imports. And we did the same with CO2 sources and sinks. We then transferred the estimation of others, not ours here, per sector on our point data based on various activity data, and managed to build, in fact, a grid of high probability production and consumption for sources and sinks. And that is where we are as of today. Next slide, please. As we are in the process of selecting case studies for the economic assessment. For now, we do not know yet the outcome, as it's still ongoing, and it should be finalized in June 2021. But those kind of fact-based exploratory studies done at EU level for now could be beneficial to all UNECE countries. Thank you for your attention.
Thanks, Gael. Here brings to my mind one comment. Tatiana Mitrova was referring to practical projects, and let's go to practical projects. In terms of transportation, one of the most practical things we can do is just to assess what we have, what we already have in underground, the pipes we have underground, because this is a quick, would be a very quick start just in the development of the hydrogen. So thanks, Gael. This is a very interesting project, and let's hope that our colleagues provide the data to get the most complete picture possible, and then for the benefit of all of us. So thanks, Gael. Let's check. Wait for the questions at the end, because I presume that this project, this concrete specific project, may concile some questions. Then let's go quickly to the third speaker this afternoon, Eva Henning, on the perspective of one of the very important player, which are the distribution companies. Eva, please.
Thanks. Thank you very much, Francisco. So now we are jumping to the other end of the value chain, to the distribution grids. So my name is Eva Hennig. I'm working for TÜGA. Next slide, please. So we're sitting in Munich, so that's what you can see at the moment here. Next slide, please. Yes, thank you. TÜGA is a large group of that was too fast, of 100 utility companies all around Germany. We operate gas, electricity, and district heating and water grids. The whole group together has 2 million customers, and we are operating 90,000 kilometers of gas grid. This is all distribution grid. We go into all levels of pressure, so we go up to 80 bar, but we also operate low low pressure. What we have is we have quite a lot of practical hydrogen projects, which are just starting now. We had our first electrolyzer running since 2014, but now we are going more into practical projects where we look at the blends of hydrogen up to 20%. Blending is a very important first step for us, because we can use the existing infrastructure and we can also use the existing appliances with the customers, but we also look into pure hydrogen projects, because we think that in time we will move ahead from blends also to pure hydrogen. And we are a member of the Clean Hydrogen Alliance Roundtable that Abel has just presented. We are the distribution company in the roundtable. Next slide, please. What I would like to tell you is we have a parallel system in most of the countries. So we have the TSO level and we have the DSO level. In Germany, we will have at the TSO level probably mostly pure hydrogen grids parallel to the methane grids. And the very large customers are connected to the TSOs. And of course, you have the underground storage is connected to the TSOs. At the DSO level, and maybe this is the specificity of Germany, 99% of the industrial consumers are connected to the distribution grids. More than 70% of the consumption of the industrial consumers and nearly all of the CHP plants are connected to the distribution grid. This is probably also one of the reasons because we have very large regional distribution grids operating also high pressure pipes. So what we see at the moment is that we are planning a blend of hydrogen into the distribution grid, but we are also looking at pure hydrogen grids as soon as we have the backbone, the famous European backbone, also in Germany, coming from the TSOs. So we could inject pure hydrogen also to special customers. What we are looking at are the CHP plants, for example. You all might know the taxonomy in Europe. The taxonomy is very strict. So the CHP sector is one of the first that has to decarbonize. But we also have very large industrial consumers who have interest in pure hydrogen. So we will have a stage-like approach coming in the next few years. And it's blending, of course, is the first very important step because we see this as the fastest step and also as the most cost-efficient step. Next slide, please. What we also will see is that we have localized production of hydrogen, and we all know the colors of the hydrogen. So you have green hydrogen with renewable electricity, but it depends very much on where you are in the country. For example, when you look at Bavaria, we don't have a lot of wind farms here. Of course, we have sun, but with the sun, it's very hard to heat in the wintertime. So we don't only look at renewable hydrogen. We also look at the pyrolysis, which is called the turquoise hydrogen, because we think that the pyrolysis is a very good possibility to produce hydrogen whenever you need it and to combine it with the electrolyzers. And for TÜGA, we are looking at 2 pyrolysis projects in the future because this is technology that has really picked up in the past months a lot of traction. So what is happening now? We have in Germany 740 DSOs. This is quite an unusual situation that we have so many DSOs. And each DSO, of course, is not just one entity. You can also split the grid of the DSO. You can section it. And then depending on the hydrogen input and whether you have biomethane, you can start having pockets of blends of hydrogen, but you can also have pure hydrogen. You can also have pure biomethane to make the most out of the local production of renewable hydrogen or pyrolysis, and then also connect up to the TSO. So this is a development that we are looking at the moment. And until mid-April, all the DSOs in Germany have to gather their intel to say how much hydrogen will they see and will they need in the next 10 years. And this is going into our national TSO development plan. Or we hope so. It depends, of course, on the regulator. But it's a big effort that we get everybody together to really look in detail what kind of customers do you have connected. Next slide, please. That's also my last one. So at the moment, we have 1,400 DSOs in Europe. We work closely together. We want to assess how much hydrogen you can blend into the grid, what you would have to do to move from a blended hydrogen into a pure hydrogen. the TSO backbone, of course, is very important for all of us because security of supply comes also from the TSO grid. You can feed together with local production, but you need to have the backbone. We have many member states where a large amount of industrial consumers is connected to the distribution grid. So what we see is to just concentrate on 5 or 6 industrial clusters will never create a market. So what we need is a market, and what we need there, we need to have the regulation and the legislation coming up at the European scale, that we can start to inject the hydrogen into the grid and to produce it. We need to have security for the investors, and that's it's a perfect combination between the DSOs and the TSOs to look at the market. And we don't want to have separate market at the distribution level. We want to have a huge market. We want to have the hydrogen traded as we see it in natural gas. We also want to see competition, different injection points. And what we think is the more customers you have, the more transport and distribution of hydrogen they have, the more stable a market could be in the future, and not only depend on just a few producers and a few customers. Then you are also able to convert a whole grid into the future. So for us, hydrogen is really one of the big issues, and we're putting a lot of effort and a lot of money in the whole transition. Thank you very much.
Thanks, Eva. Seems to be a quite wise approach, for sure. Here I dare to have a comment. Yeah, we achieve in some cases more than in others an integrated gas market in the EU. I say not in all the places with the same level, but and now we have another gas in the grid, either mixed or pure, which is hydrogen, so that it will be good just to continue with the aspiration of keeping this integrated gas market with a lot of injection points, and then using the network for just connect the production sites and the consumption sites. And then this is just from my own, I do believe that we already have some good regulatory framework that so that it could be relatively easy to mirroring that framework, and then use as inspiration or as base, or just probably copy paste and a small adaptation to the hydrogen. Because in between, as you say, hydrogen and natural gas will go together together, that as much as mixed within mixtures and blending. So thanks, Eva. Also, we check just for the discussion. Probably somebody will ask, and then we need also your views on the questions we will have here in the agenda. Next speaker is Thierry Leperc. So floor is yours, Thierry.
Thank you, Francisco. There's a lot of confusion about hydrogen. I think one of the previous speakers mentioned it. Is what is hydrogen? There's hype. What is hydrogen? And I would like to start saying there are two ways of looking at it. One is hydrogen is a climate issue, is a climate product that deals with governments. And the issue is carbon and how you handle that. The problem with that is that it's very obscure. What is the price? What is the right price? Who buys what? Is there a market? Who finances what? It's very complicated. It's absolutely confusing. There is another way of looking at things, which is hydrogen as a commodity. Like natural gas, like oil, like coal. It's a commodity that is delivered to customers at the right price with the right infrastructures. This is what we're talking about here. Infrastructures to deliver the right product to the right customer. But it's very important to understand what we're talking about. And so a few words about who I am and who I'm representing. I'm here as the spokesperson for a very large initiative, which is, as you previously mentioned, Francisco, is HyDeal. What is HyDeal? Is 40 companies who got together, including
Please again, could you please mute microphone if not
Якщо
speaking?
вони
Just,
со мною не обсудят, то я, конечно, буду використовувати це як занепокоєння.
excuse me, just those not speaking, please mute microphone.
Ага.
You have the opportunity to intervene later on. Thanks, Thierry.
Okay, no problem.
Ну ти не проходь цю місію, хай вони обломаться, Віка. Я хочу, щоб вони були.
Mrs. Tinkovich, can you get going yet?
І чим такої?
No, whatever.
Ну, типа, что должно быть, типа, at least, да? Столько, это правильно?
Ala, it is possible that you mute, please?
Гена, дальше.
Branko, could you check whether can be muted?
Дальше.
Trying to. Yeah, I've been trying. Hold on.
Thanks. Go ahead.
Все понятно, допустим.
Okay, can I start again? Okay,
Yeah,
so,
please, sorry.
so hydrogen as a commodity. What is hydrogen as a commodity? It's hydrogen supplied
Да,
as
слушай, да, но это такое, они желают это все дискуссировать, правильно? Я пишу Андреас,
Branko,
I'm trying to.
it is possible to mute all except the person that is.
Yeah, we are using now this Zoom that we haven't used before.
Right.
Yeah.
We are learning. As Eva said at the beginning, we are all of us are learning.
Алла, выключите, пожалуйста, микрофон.
I have no control.
Oh,
I have no right to mute people. Well, let's hope that this conversation will stop.
Maybe somebody could talk to her. I mean, she probably hasn't.
sorry. Apologies. The technology. So let's try to continue. Thanks, Terry.
Sure.
Allah, you are the host. You can mute yourself.
I mean,
Yes.
Allah, please mute yourself.
Okay, now I think, okay, fine. Good. Sorry, we made it. All right.
Apologies, Terry, go on.
With technology. So commodity. What is hydrogen as a commodity? Hydrogen as a commodity is what serves customers. What do customers want? And I'll take a very concrete example of what we're doing with this. So Hydeal, sorry, getting back to Hydeal. Hydeal involves upstream players, hydrogen producers, solar electrolysis injection in the gas grid, gas TSO. So we're very happy to have Enagas. Enagas is one of the very important participants. We have Snam from Italy, we have OG from Germany, we have GRT Gas and Terega from France, and we have downstream players. But a commodity means two things. It means cost and volumes. First thing that customers want is a product which is delivered in very big volumes and at the right price. And the whole construction of the value chain needs to start from that. Because if you're building something just for climate purposes or small projects, you're never going to go satisfying customers. I'll give you an example of customers. When you have the largest steel company in Europe, which today says, I need to go zero carbon because my very survival depends on it. If I produce steel which has beyond 1 ton of carbon in it, I'm dead, which means that they need millions of tons of that product at a price. What is that price delivered? It's a very simple price. It's the same price all across Europe. It's 1.5 euro per kilogram delivered, which means something very simple. Is that you can only use pipes to deliver. Forget about trucks. You want to be nice with trucks? Forget about trucks. Trucks will cost you more than 1 euro per kilogram to deliver. Pipes are the way to go, and I think the presentations that we heard before are showing the way, and it means either reusing existing pipes, repurposing, or in certain cases rebuilding pipes next to the existing pipes. Storage is just as important, we have not mentioned storage. Storage is going to be absolutely fundamental. You need underground storage, whether it's aquifer or as well salt caverns, and having a systemic view on how you produce the product, transport it and store it and deliver it to the customers is fundamental. But let's have a minute on the economics. I think everyone should understand that hydrogen is a very, very tough challenge in terms of economics when you get to a real market. And the only way, by the way, you're going to have the volumes is because you have the cost, and you have the cost because you have the volumes. Both go together. And the millions of tons go with very big pipes go with millions of tons. And all of that is conditioned to delivering the product to 1.5, which means that if you have a cost of transmission and storage of 0.3, which is roughly what we've modeled at with the Ideal platform, which there again brings across all these value chain players, it means that only certain areas are going to be source of the product. And from the modeling that we've done with Ideal, there's a very simple message. Solar is by far going to be the biggest source of hydrogen. Why? Because that's the only way you can do 1.2 euro per kilogram production costs, which is 30 euros per megawatt hour, which means that if you're using green hydrogen, you need power at 15 euros per megawatt hour, 15, which means wind is out, and means solar is only possible in high irradiation countries. Now, in the European Union, just 2 countries qualify for that. That's Spain and Portugal. Forget about Italy, forget about France, forget about Germany. When it comes to the broader region, North Africa comes in, Tunisia and Morocco, among others, and further east, it's Turkey. That's the way you're going to have the very big solar resource to go. And then the pipes themselves need to connect those areas where you're going to have mass scale production of green hydrogen at very low cost from solar through those pipes. And what we're right now working with all the gas TSOs is how are we going to move all these products and when? And I'll just like to say there are 2 phases for it. One we call phase 1. Phase 1 is going to be blended. Why? Because when and now I'm taking another hat, which is that of an entrepreneur, solar entrepreneur, when my company is going to produce hydrogen in Spain from 2022 onwards, we're talking about production from next year onwards, we're not going to have those pipes ready. Enagás is working hard, but unfortunately they won't have those new pipes hydrogen pipes ready, and it'll take some years before it's. Now the big question is, how much can we get there? It's a discussion that we're having with Enagás, with the Spanish government. And overall, what we need to have is a capacity to inject as much as we can. The business model behind that being guarantees of origin. You have the same business model in biogas, same business model in green power, and same business model and for other renewable energy sources. What you want to have in the second stage, because the big volumes will only come once we have the biggest pipes on. You want the fastest possible decision-making on pipes. And what we have today is a race. It's a race among gas TSOs together to make these investment decisions, to have the right regulatory framework. Is it going to be regulated? Is it going to be concessions? Things are being discussed in various countries. Now, what we need to have in order for all this to make sense is infrastructure is central. So I think our work stream is fundamental, because without midstream, nothing exists. But midstream doesn't exist without upstream and downstream. And so the reason, the business model, all of this is based on is the fact that you have very big volumes that need to be injected. So the first thing is, where is going to be the upstream, the competitive upstream, not the government subsidized upstream with tiny production numbers. Forget about this, they will never get you. So what you want is to have the millions of tons of annual production coming upstream very quickly. Our goal at Ideal is 3.6 million tons by 2030, 95 gigawatts of solar, 67 gigawatts of electrolyzers. Just this grouping, just for Spain and Portugal. Doesn't even include Italy and Tunisia, and not even the Eastern branch. So we're talking about extremely big volumes that are possible because you aggregate both suppliers and you aggregate demand. So in a nutshell, and it will be interesting to have a discussion about that, the key today is not to spend time with government. The key today is to bring industry players from the upstream to the downstream together around the midstream, and obviously finance. The good news about finance, and we have among Ideal infrastructure funds, we have the European Investment Bank, we have very big money. We're talking about hundreds of billions of euros ready to be invested in these things. The only way they're going to be invested is because they have sustainable, bankable, long-term contracts with off-takers at the right price. So what is needed essentially is not, there again, government programs, local test projects and everything. This is the past. We need real business models based on suppliers, customers, and finance. And then again, midstream is the key. The gas TSOs are going to have an immense role to play.
Thanks, Thierry. Sorry if this is a very Iberian-centric, but this is your project. I mean, your project and your vision. So thanks, Thierry.
Excuse me, what centric?
No, Iberian-centric, Iberian Peninsula.
No, it's not Iberian-centric. We're working right now Italy and Tunisia.
Yes,
and yes. To work on Turkey. No, it is, and to be on the Middle East. But you know what? You need to talk about where is the resource. And it's like, growing bananas. If you want to grow bananas in France or Russia, you're not going to be very successful. The same thing goes for hydrogen. You need to go where the resource is. And the resource is going to be very cheap electricity, and very cheap electricity comes from solar. So in the end, it's going to be from the south. That's the fact of life.
Thanks perfectly with today's workshop and tomorrow after tomorrow just session of the group of expert guests. Fits perfectly. So last, not least for sure, is Siegfried Kiss. Floor is yours. Happy to see you again, Siegfried.
Francisco, can you hear me?
Perfectly.
That's perfect. Again, many thanks for the opportunity to share some slides concerning storage of hydrogen. It is a great pleasure and honor for me to be part of this workshop. And because, URAG Austria is a small company with about 200 people, but we have a major impact in Austria and the central of Europe because we are operating underground gas storages, UGS in short, with a volume of about 70 terawatt hours and 30 gigawatts of withdrawal capacity. And we are very innovative concerning large-scale hydrogen storage. So let me show the first slide. Yes. Some basic numbers why global hydrogen demand will increase storage demand. So global natural gas demand in 2019 was approximately 4,000 BCM. That means 40,000 terawatt hours. The global gas storage demand was 424 BCM, so roughly 4,000 terawatt hours. So we have a relation of 10 to 1. This relation is more or less valid all over the world. The global hydrogen demand in a conservative scenario, and there are a lot of prediction studies around. Let's suppose the number from the World Hydrogen Council. This is 27,500 terawatt hours a year. And then we exclude the hydrogen, which is needed for transport, to compare with natural gas demand. And then we end up with 20,000 terawatt hours a year hydrogen demand in 2050. So with the same relation, 10 to 1 leads to 2,000 terawatt hours gas storage demand. So far, so good. But 1 cube of natural gas has approximately 10 kilowatt hours per cube. And 1 cubic meter of hydrogen has 3.3 kilowatt hours of energy content. So the gas storage demand will be 660 PCM. And this means a 55% increase. So at the end, there is need of conversion of the existing UGS, and new gas storages are definitely necessary. Next slide, please. Two main needs drive this demand. First, it's the need of hydrogen exports and imports to balance the demand and supply. Here, as an example for Europe, RAG is involved in the project for importing hydrogen from Ukraine, and this means a significant increase of storage capacities for hydrogen in Central Europe. And the second need is for interseasonal energy storage. For example, and here in Austria, and this is valid in many countries, with the data for a policy scenario of 100% renewable electricity production in 2030. During summer period, excessive electricity production has to be transferred to a long period demand in winter days. Hydrogen as an energy carrier is the only way to balance the energy system and provide security of supply 24/7, 365 days. To store hydrogen on a large scale is not an easy task. So therefore, RAG started, and please the next slide. We already started 2013 with a research project called underground sun storage. The first in the world, we injected 10% of hydrogen admixture in a sandstone reservoir and investigated the integrity of the whole storage system. In a follow-up project, underground sun conversion, we investigated the conversion of hydrogen plus CO2 in a reservoir because it's converted into methane by the help of microbes called archaea. Our recent project is Underground Sun Storage 2030, where we investigate 100% hydrogen content for storage. I think in a very short and presentation, I'm looking forward for questions, and I'm happy to answer if it is possible.
Thanks, Siegfried. Yes, I told that this was very innovative, and your ideas could be very inspiring for this forum. So thanks for making the time. I knew that that you had conflicting agenda, and you decided to cancel the other compromise to be here. So thanks, Siegfried, for that.
You're more than welcome.
Then we have some 20 minutes for the debate. We may start with what we have in the chat, but we have also some few questions. Also a question from your side, from the panelists are welcome. This one of them is from Bagdi Hosha. From Medreg is asking about the role of national regulatory authorities on hydrogen. I think it's very interesting. I would like to start with this to all of you, whoever wants to of the panelists to intervene. If not, I will do myself. But please. You are here, Siegfried, you are on the screen, so yourself, you can start.
Well, thank you very much again. And I think all the other panelists mentioned a lot of aspects which are very, very valid. At the end, it's the question of price. And it was mentioned that $1.5 or euros per kilogram is the target price. How can we really provide this price for the customers or the consumers in the different qualities of hydrogen, because this part was not mentioned in this panel. If we are talking about hydrogen, we are talking about different quality levels. And I'm not sure if this is really well known in the overall audience. How do you see that on the board with me? The different qualities of hydrogen, because it's tremendously different in prices if you are talking about the quality of 1.8 or a 5.1 or a 7.1, for instance.
Thierry, you want to say something?
No, the quality of hydrogen from electrolysis is probably as good as you can get. It's far purer than what you could get from, say, biomass or natural gas or whatever you would want. That's the purest product. To be very frank, some people tell us, you know, you're using champagne and you want people to bathe in champagne. That's too bad. And we're saying, you know what? If champagne has the cost of water, it's okay, because that's what you want to have. So the good news about this champagne is that, yes, it's going to be available in very large quantities with the top quality for all the uses that you need. So this is where people need to have a systemic view of how you can adapt. If you're in a transmission and storage business, how can you adapt this? And very much like the presentation of storage. Storage today has an immense potential here in Europe, north to south, just not on transmission, but also on storage. So that's where you need to have, then again, the scale effects and then quality of the product. It's not quality versus volumes. Quality and volumes actually go hand in hand. You want to satisfy every customer.
Maybe Francisco, if I can come to the question of the regulator. So what do we see as the task of the regulator? We think that the regulator has an important task. We came, when you remember 20 years ago, we came from negotiated grid access. We tried it in Germany. And if you look at the market, you have to make sure that everybody's on the same plate. And this is part of the regulation. So if you have a regulation which is clear to everybody, then you can give access to plants to produce hydrogen, to inject the hydrogen. You have to make sure that they all have a chance to connect to the grid. But it's the same also for the customers, so they are able to plan ahead. And this is why a stable regulation is very important for us. And we come from a very stable gas regulation and gas directive, which has a long history. And sometimes I'm wondering, if I hear, oh, let's just do a small hydrogen regulation. There is no small hydrogen regulation. As soon as you connect more than 5 or 6 customers and 5 or 6 producers, you're looking at all the regulations and all the rules that we already know of today. They have a sense. They came from somewhere. They came from the past, and they came from the experience that we had in the beginning when everybody tried to do negotiated grid access. So, which means that, of course, we also will have privately owned hydrogen pipeline systems. They are already there today, and they have a task, and nobody says that they have to go into the regulation. It just depends on what kind of market they want to serve. But as soon as you connect more customers, as soon as it's getting complicated because everybody wants to be part of it and everybody wants to have a fair grid connection price, you have to have a stable regulation, otherwise nobody can plan ahead.
Do you want, Eva, take also this question for Niels? On the role of microgrids and combined with local hydrogen production. I mean, this is for you, Carly.
Yes, I see the role of microgrids in the sense, well, micro seems to be very small, so a microgrid can be anything between, let's say, a couple of customers and a whole distribution grid with a couple of hundreds of customers. It depends very much on what kind of hydrogen production you have, because, you know, as soon as you jump into the conversion into pure hydrogen, you cannot turn back. You only can jump once because you have to convert the appliances. Means if you have a microgrid which is running on pure hydrogen, you have to make sure that you always have the ability to deliver the pure hydrogen throughout the whole year, which means that you have to have a certain storage in place to make sure that even if the wind is not blowing and the sun is not shining, you are still able to deliver into the microgrid the hydrogen. This is why when we think about microgrids at the moment, we think more about blends, because they give us the possibility to have a bit of a shift depending on what the appliances can do. But of course, the microgrids are important to start to develop. We look at the hydrogen-ready boilers which are coming up. So we see those energy island, the hydrogen valleys, the smaller projects where you have fuel cells, where you have residential consumers, where you have fueling stations. So you combine all those projects together to have an efficient showcase of the different things you can do. And most of the distribution grids can jump to 100% of hydrogen without much happening in there, because they are built in polyethylene. But yes, I definitely see them, and they are very practical to learn.
Thanks, Eva. Siegfried, this seems to be for you, the Behnam Sakeri. If it is possible to estimate something that you already said, hydrogen storage demand for different countries by linking that to H2 demand and available gas grid. What is your opinion on this?
Well, probably if you can repeat the question, because I can't find the question.
You know, the question is 3:34 p.m. I tried to read. I think that probably was partially already addressed by yourself, but it is thanks, Siegfried, for interesting insight. It is possible to estimate hydrogen storage demand for different countries by linking that to H2 demand and available gas grid. This is the question.
A very tricky question, because because as you know, and if you want to compare it with the natural gas situation in these days, you have to be very, very clear what is the specific issue of the specific country. If you get LNG, for instance, you have a different approach and a different necessity for underground gas storages. If you have the consumer near the coastline of the LNG, if you have to go into the center of a country or a region, then it's a different story, because you have to transport it via pipeline. And then the only way to balance a system, to balance the market, is to have storage available near the consumer. And so I can't give you a value for the storage demand in the different countries, but a first indication should be the storage demand of in comparison of the natural gas demand in these days, because you have the first roughly approach. I think it's enough for each specific country. Mm-hmm. Because we have 700 storage sites all over the world, and many are developed in specific areas like China or in these areas, and in other parts of the world it's different if you have production near the consumer part.
Somebody wants to say something here?
On the storage side, what we're talking about is immense needs. I'll get back to the numbers of Hydel. And then again, 3.6 million tons delivered by 2030. We need 7,700 kilometers of transmission, and the storage capacity that we need is in excess of 50 terawatt hours. And that 50 terawatt hours actually represents more, if you take about the volume, which we'll take, because obviously the problem with hydrogen is that it takes more volume than natural gas, and it cannot be used. You cannot reuse every single one of those. You know, there's issues with porosity of materials for certain certain materials. So the issue here is that we are going to need a vast expansion of existing storage capacities, probably in the factor of 5 to 10 in the next 10 to 15 years. Not every single country is well positioned for that. For instance, if I take Western Europe, Italy is very badly positioned, geology-wise. France is okay. Spain is a bit okay. Germany has a great, super big salt caverns in the north part of the country. So does the Netherlands. So what we have here as a challenge overall is not only converting these pipes, the thousands of kilometers of pipes, but really rushing on the storage site. And I have a piece of advice for those who want to make a killing in terms of investments: go for these underground caverns that are today underdeveloped. Then again, it's going to be probably a rush in Germany. That's going to be an immense opportunity, and storage needs to be seen as a systemic thing. You're not going to store next to a factory, because that would be very, very super expensive storage, and you will not do seasonal storage in tanks. That doesn't work, as there's no economics behind it. So it has to be seen together as a concept with the whole transmission, not just at a national level, but at the international level, pan-European level. And this is where a number of business models are going to emerge on this midstream side.
Thanks. I have just a question, but address as somebody asking me to ask Gael if whether if they have some estimation, some assessment on the range of cost for the reuse of pipelines. We were speaking about cost efficient. We are aware that it's cost efficient, but Gael, do you have, from your two, let's say, big consultants, just groups, you have some estimates, roughly speaking, ranges of on the cost to reuse the current pipeline systems?
So at this stage, I'm sadly going to say no. So we did not yet perform the case studies that are planned, and it's within those case studies that we will have some specific cost assessed, and we'll compare to new build. So, but what I can tell is that a big number of the pipelines that we are studying in terms of kilometers, it's, I mean, can be reused for hydrogen onshore and offshore as well. So that's what I can tell at this stage. But I'm really sorry, I cannot give any number, but I will come back and give a number once we have
no
the
problem.
study
No,
done.
no problem. No,
I can do it for some, because that's what we did in Ideal.
Excellent, Thierry. Go for it.
Sorry. No, but just to say that we now are people, with the consultants, and we've modeled it 0.5 million euro per kilometer for repurposing, and 2.3 for new pipes. That's 2.3 million euros per kilometer for new pipes.
So really efficient.
48 to 56 inches.
Yeah, exactly. So we are close to the end. So before we finish, I have just one question. We are in the UNECE, and the question, global question I have here is how could this UNECE facilitate international and cross-sectoral collaboration to increase awareness and public acceptability of hydrogen and to accelerate the transition? How we can work on this segment of transport and storage? How you think that UNECE can't jump into this? Do you see a specific role to facilitate, just at least in the Northern Hemisphere? Any of you? Because this is a very open question.
Or if I may say, the world beyond the European Union.
Yes, thanks. I mean, there is a role for sure. This is today's event. This is an example that the UNECE is committed to join or to link the regions, to link the European Union, the US, the North American, the Russia, some other countries, and many others that are also connected today, even from South America. I see people from South America, from Africa, trying to also to listen to what we say. But UNECE is by having today's and in the following, we have more sessions on this topic. This topic will be a very important one in the future activities of the working of the group of experts on gases, so that the role probably we will ask you in the future also to provide insights. And something else,
Francisco.
Yeah, this is Branko. I missed something?
No, not at all. If I may add something,
yes,
let's
please.
give our panelists a few minutes to think about this, because I think the answer to this question will be highly interesting, not only to this group, but to everybody else who will join us in the plenary in 10 minutes from now. So what I suggest is that you all stay here tuned, and when we break for a few minutes now, and then we'll again log in using the link you used before, if you recall, the plenary link. So use not this link, but different one that is for the plenary. So in the plenary, I would like to ask you all to help Francisco and me in explaining what the key takeaways from our discussion, what are the key points? How would you summarize in 2 sentences what you just told us for the rest of people to understand? I've also put down some takeaways, but I think it's better to hear it from you.
Because all the others will do the same, right?
Yeah.
All the others will do some. Okay.
Exactly. So for me, one of the key things, and I'd like to simply check with you if I got it right or wrong, is, you know, before we have a huge polyethylene pipeline from Russia to Europe, you know, we are going to have many smaller networks that are local. And what also we heard from Ms. Mitrova is the same thing, that the idea is that we will have a cluster of hydrogen production consumption sites that will slowly grow like crystal, and then eventually will move to cross. But still, the UNECE can help even with this approach, which is not cross-border, long distance, but rather many clusters that work in some sort of synchronous way. So this is also an angle to explore. So if I may ask you, I think the time is now, Francisco, to thank our speakers, all of them, Berlin, Gael, and Thierry, and Eva, and Kiss. Sorry for misreading your name. So that I'm seeing Siegfried. Sorry again. Siegfried. So
keep it short and simple, you know.
Yeah. So we have about 5 minutes of a short break, and then please log in again back to the plenary.
So that Branko's suggestion is just in the plenary, everyone is asked to provide couple of takeaways. Then we will put together. We will gather together, and then include in the conclusions.
1 minute digest. Yes.
Okay. Thanks. Thanks everyone. Disconnect here and go to the main stream. Thanks everyone for participating. Very interesting.
Thank you.
Thank you very much. All the best to all of you. Bye.
All the best.
Bye.